Okay, so we're going to look at exponential functions to begin with. So you've seen these at GCSE. Okay, so this is just what you've seen already. Now, an exponential function means that we've got y equal a value, whole number or fraction. Now, we are going to stick with positive values, okay, to the power of x. So an exponential is where we've got power of x. And this is when we get something like exponential growth or exponential decay. So the growth looks something like this and the decay looks something like that. Okay, now at GCSE you did draw these using a table of values. So we're going to start there and then see how we can go about sketching these knowing certain facts. Okay, so we're going to do 3 examples. Here's the first one. So it says draw y equals 2 to the power of x, hence sketch y equals 3 to the power of x and y equals 1.5 to the power of x. Okay, now at A level, in general, we're looking at sketching. Okay, however, as it's the first example, it'll be helpful for us to draw it and just to see where the numbers come from. So when we're drawing anything, it's always good to have our table of values. So if I give x and y, and let's go between -3, -2, -1, 0, 1, 2, and 3. Struggle a little bit for space, as you can see. Okay, so if I think about these, this here is 2 to the power of -3. Now we should know that as 1 over 2 cubed. So this here is going to be an 1/8. Okay, similarly I get a quarter and a half. Anything to the power of 0, hopefully one of you said a 1. And then 2 to the power of 1 is 2. 2 to the power of 2 is 4, and 2 to the power of 3 is 8. Okay, so I've just neatened that up and drawn myself a graph. Now, as you'll notice, no matter what the value x is, y is never ever going to be negative, okay? Because we'll just get it closer and closer to 0. So we'll now go about drawing that. So if we start with 0 and 1, so I will do it in black actually. So I've got 0 and 1, 1 with 2, 2 with 4, and then 3 is over here with 8. Oh dear, a little bit higher. Okay, now going backwards, I'm going to get closer and closer to 0. Now, it's never, ever, ever going to touch 0. So what we have is we have an asymptote on the line y equals 0, or the x-axis. Now, if we draw those with a nice smooth curve, we should get that classic exponential type graph. Okay, so now we need to go on to the sketching part. So we're going to start with sketching y equals 3 to the power of x. Now I'm just going to think about a few key points here. Okay, so first of all we think about where it crosses the y-axis. Now when x is 0, 3 to the power of 0, anything to the power of 0 is 1. So it's going to go through that same point there. Okay, now if we think when x is positive, 3 to the power of 1 is 3, so it's going to be slightly higher. 3 to the power of 2 is 9, so it's actually going to be way higher. So it's going to sit higher than that original y equals 2 to the power of x curve. Okay, however, when we think of when x is negative, here, I get that 3 to the power of -1 is a third. Now, a third is smaller than a half, so it should now lie below this graph. So 3 to the -2 is 1 over 9. So that's below a quarter. So although it sits above the graph on this side, actually it reaches or tends towards 0 faster as it is negative. Okay, so I'll just join those up to make a nice smooth curve again. Bit steeper. And then there it is underneath. Very hard to do. Okay, so I've just added some quick notes there that the y-intercept's always 0, 1. As I've just said, when x is bigger than 0, we get the curve 3 to the power of x bigger than 2 to the power of x. And when x is less than 0, then it is smaller than it. Okay, so now I'm just going to go about sketching y equals 1.5 to the x, and we're going to think a similar thing. Now the y-intercept is always going to be 1, so it's going to cross at this same point here once again. However, if we think about positive powers of x, 1.5 to the power of 1 is going to be 1.5, so that's going to be shorter than the curve. Okay, and then it goes up to something like 1.25, and then I'm not sure, just above 6 I imagine. Okay, so here, when x is bigger than 0, I get that 1.5 to the power of x is smaller than 2 to the power of x, because that number there is smaller than 2. Okay, now, if we think about when it's less than 0, well, we're going to have 1 over 1.5 when we have a negative 1. Now, that's going to be smaller, bigger than 1 over 2. Okay, so 1.5 to the power of x is is going to lie bigger than 2 to the power of x for these negatives. So it's going to lie just slightly above this curve here. Okay, so when we join it up like that, hopefully we get something. Okay, it's a little bit messy, but that should give you the idea. Okay, let me know if you've got any questions. Now, before we move on to the next example, I just want to make it clear what I said at the start. We're only going to look at positive values of a. The reason for that, if I just look now at my table of values for y equals negative 2 to the power of x, because two negatives make a positive, we get this kind of oscillation between the negative and the positive. So I get minus an 8, positive a quarter, minus a half, positive 1, minus 2, positive 4, minus 8. Now this isn't very helpful for us to graph, so therefore we won't be looking at this at A level. Okay, moving on to example 2. Okay, so for this second example, it starts off a similar way to last time. So I've done a lot of that work already because it would already have been on the whiteboard, I'm imagining, if I was at school. So we've got sketch y equals 2 to the power of x, and then y equals a half to the power of x on the same axis. Now this is the main thing that we're wanting to focus on for this example, is this y equals a half to the power of x. So we've just discussed that y equals 2 to the power of x. It's going to go through the axes at 1, as will any exponential graph, because anything to the power of 0 is going to be 1. And it goes up this kind of exponential growth here. Okay, might have not drawn it perfectly, but it's a bit hard on this little whiteboard. Okay, now it does say to sketch, but because this is the first example, I'm going to show you why. Now, one important thing I want you to know for yourselves is that a half to the power of x is the same as 2 to the power of minus x. Okay, because 2 to the power of minus 1 is a half. Okay, so the kind of shape that we're going to see will be the same for negative powers of x. So fractions and negative powers of x are going to be linked. Okay, now if I just think about a half to the power of minus 3, I'm going to do that a bit in detail. So if I do a half to the power of minus 3, flip the fraction for the negative power, I get 2 over 1 to the power of 3. Now we don't need to have that 1 on the bottom, so that just becomes 8. Okay, so we kind of have the opposite pattern for here. So I get a half to the power of minus 3 is 8. Similarly for minus 2 it's 4, 2 squared. Minus 1 is just 2. And we already know that anything to the power of 0 is 1. Okay, and then if I think about a half to the power of 1, it's just going to be a half. Oh gosh, not very good. Messing up like I usually do. A half, and then a quarter, and then an eighth is a half to the power of 3. Okay, now I've not really left much space for this, but if I now sketch this out, at minus 3 I'm going to start all the way up here with minus 8. Minus 2 I've got my 4. Minus 1 I've got 2, and then it crosses at the same point every single time. And then here it's still going to tend towards 0, but this time when x is positive. Now that is a lovely symmetrical graph there, and that is because 2 to the power of minus x, well, it's a reflection in the y-axis in that x direction. Okay, so just neaten that up a little bit, and then this is the really important fact that I want to take from here. Okay, so if we've got a function which is sometimes called y or f of x equal to a to the power of x, if a is in between 0 and 1, i.e. a is a fraction, a proper fraction, this will give us exponential decay. Okay, which is where we start very high in the negative, but then we're going to go towards 0 as it gets longer over time. Okay, so as x gets bigger, it gets closer and closer to 0, whereas if a is bigger than 1, so it could be 1.1, it could be 10, it could be anything like that, we get exponential growth. A bit like coronavirus. I think it's got something like 2.5 maybe is what we originally thought it was going to be. And that will get bigger and bigger and bigger, because every 1 you go along is going to multiply by whatever value of a is. So in this case, every 1 we go along, it doubles. Okay, last example before you do some questions is sketch y equals a half all to the power of x minus 3 and give coordinates of the y-intercept. Now here is when we're going to have a little bit of cross chapters, because we've got a transformation, okay, which I'll just quickly remind you of. So if we're sketching, we know how to sketch f of x, which is a half x. Okay, we've just discussed that. That's going to show some sort of exponential decay and look something like that. Okay, crossing here at 1. Okay, so if we now think this is going to become a half to the power of x minus 3, that means the function is becoming f of x minus 3. Okay, now a quick reminder, this means that we're going to translate, now as it's in the bracket we make it positive 3, and it's going to be in the x direction. So we're going to shift this graph 3 to the right. Okay, so wherever the value of 3 is, that's going to be my y-axis intercept. Now, a half to the power of, minus 3 is going to be 8. Okay, we've just done that in our last example. So when I sketch out a half to the power of x minus 3, I know that it's going to cross through here at 8. It's going to keep going up exponentially, and then it's going to tend towards 0. Something like that. Okay, really bad sketch. You're not ought to worry that too much. It's a bit harder with a whiteboard rather than a piece of paper in front of you. Now, the only other thing to note about this question is the following. Really, really nicely, another way we could have done this is we could have thought that a half the power of x minus 3 is the same as a half the power of x times a half the power of minus 3, because when we multiply we add those powers, so that will x add minus 3 becomes x minus 3. Now a half to the minus 3 is just the factor, it's just the value 8. So I'm doing 8 times a half to the power of x, or 8, which is a stretch in the y direction, scale factor 8. And that's exactly the same because where I have 1, I've now got 8. And it actually works all along, so either of those ways are valid. And that should leave you now prepared to do exercise 14a. Please ask me any questions.